Okay, hello everyone. Today we're going to start graphing radical functions. Okay, we're going to graph them. Guys, basically we have two more topics to cover with radical expressions. And we just had a test, right, on this part right here, the nth roots, the negative and fractional exponents, and we looked at properties of exponents and radicals. All right, we added them up, multiplied, divided them, rationalized. All right, now we're going to start graphing them. All right, then after that, we're going to solve radical equations, okay? All right, again, today's objective, to graph basically square root functions. That's what we're looking at. It kind of looks like this, okay? The essential question, how do we graph radical functions? Guys, you can use Desmos too, or you can pop in there, no problem. We're going to do them on a worksheet though here today. Guys, just to review, I really want you to understand what a function is. Remember, we could identify a function from its graph by using the vertical line test. The idea is, again, each input has a unique output. Okay? So if I move this blue line, vertical line, back and forth, it only touches this curve in one place. Okay? But if I have a function that looks like this, it touches the vertical line twice. This is not a function. I mean, if I have a graph like this, I'll say, a relationship. All right? This is y squared equals x, something like that. Again, y squared equals x is not a function. It looks like this. However, what we do, we want to take the square root of both sides of this. And what we do is we constrict the original domain to just positive values of x. So we're just going to look at this kind of the purple or the blue curve and just disregard that red curve. So we can treat it like a function, okay? So basically it looks like this. All right, y equals the square root of x. This is the parent function. It starts at 0, 0, goes up here through 1, 1, and just kind of goes up like that, okay? Then you can go up 1 over 3. It's the opposite of the quadratic. Guys, also remember when we talked about the quadratic in vertex form, it looked like this. All right, the h moved the graph left and right. Remember this? This is when we did quadratics. The k moved the graph up and down. And remember that a in front, it flipped the graph over, upside down like this one. All right, or it compressed it or stretched it. It went up and down faster or slower, depending on the value of a in the front. And we can identify the vertex pretty easy here. In vertex form, hk, it was pretty easy to identify. Guys, the same thing works for radical functions. We kind of write it like this. Again, x minus h underneath the radical symbol, plus k is on the outside. A is in front is the multiplier, okay? And the same thing, the h moves the graph left and right, and the k moves the graph up and down. All right, the a can make the curve go up faster or slower, or it can flip it upside down. It can reflect it in the x-axis. Again, we'll be doing this here today and tomorrow. We're going to practice graphing. And just to review, guys, this is the parent function right here, y equals the square root of x. A vertical translation up and down, just add or subtract k. A horizontal translation, left and right, we subtract h or add h. All right, when both are in there, that's a vertical and a horizontal translation. You're changing the vertex where it starts from 0, 0 to a different number. All right, a negative in front will reflect it across the x-axis. All right, and a will shrink it or stretch it depending on if a is greater than or less than 1. And again, a negative a will do this. We'll do both. All right, guys, that's it. Okay, sorry, I had to change that last slide. Okay, guys, next, just complete the video check. Call it a video check since it's not really homework anymore. Guys, again, the video check, there are 2 questions that neither of them are multiple choice, right? You need to answer them with an explanation. The essential question, and explain why one graph is a function and another is not. Explain it in your own words. All right, guys, that's it. Thanks.